Okay, let's hand it over to Roman.
All right. Hey guys, so I will be talking about Scylla. Scylla is a database, Nosql database, but that's actually not why I will be talking about it. Following in the awesome footsteps left by Frank, I actually will be trying to convince you that big data at raw hardware speed is possible. And in fact, that's actually what makes me excited about the project. But let's talk about the Scylla first. So Scylla, like I said, is a new NoSQL database. It's capable of, this zillion, transactions per second, and it's fully compatible with Apache Cassandra. So, if you obligatory graphs, the throughput, basically the green one, the blue one is the Scylla, the red one is Cassandra, we're crushing it, same thing, we're crushing it even more. So, as a user, you should be happy, right? As a user, you should be happy about using it as a replacement for Cassandra. But as a hacker, you should be happier even more so, because Scylla is quite different. It's actually a C and C++ application. It's built on a very interesting concurrency framework that I will touch upon in a second or so. And it also touches upon yet another topic that is super exciting to me, and I hope it will be exciting to you as well, which is called unikernel. This is the idea of running an application linked together with a kernel inside of ring 0, so that there is no kernel, there is no application, there's just raw hardware speed at your disposal. So the comparison of the architecture is, the more traditional architecture, something like Cassandra, it basically goes through the kernel for just about anything, scheduling, memory, sort of TCP/IP. Scylla is different because, there's a kernel that is not involved. We basically have NICQs, that are completely offloaded, and everything else at the top we're managing ourselves. So the C* framework is managing all of the queues for the schedule. Memory management is the same deal. It's basically per core, memory buckets that don't require any kind of, synchronization. And the C* framework is by itself something that you really should check out, because it's a way to build highly concurrent applications using C and C++. It's built on the programming models that should be familiar to sort of modern day engineers. It's futures, promises, and continuations. And it does, like I said, full kernel bypass and supports zero kernel. Now, with that final line in mind, why do we need a kernel to begin with? Because maybe a unikernel is a better answer for all of us. And C* is unique because a C* application can be deployed on a traditional Linux system, just utilizing a Linux kernel to the degree that it needs, which is basically get it out of the way and do essentially a DMA. Or it can be the very same application can be deployed, without any changes on this cool unikernel project called OSV that, again, you all should check out. So what OSV is, it's a way of putting, like I said, your application code, so see this Scylla.so, and a bunch of what used to be a kernel code into the same memory space and running it all in ring 0. Most of the time you would use it on cloud, because cloud basically has some kind of hypervisor running anyway. So in fact, having yet another operating system kernel running on top of hypervisor is stupid to begin with, and you should absolutely not do that. But even on the raw hardware, you should actually try it out, because there are some interesting performance implications of getting CPU capabilities, such as MMU, back to the application. Because typically MMUs are reserved for things like, doing sort of memory management within the kernel itself. So like when you need to do, for example, swapping, or sort of, your application requires a memory page, MMU is the one utilized to do that, but now it's available to your application. So with that, check out those URLs, and all three of them. Seriously, like ScyllaDB, just use it. I mean, that's the lowest level of engagement. C* project, think about what other exciting, highly parallel applications you can write on it. And finally, OSV. OSV is a very cool way to run this stuff. So, thank you.
One question for Roman.
Right here. The numbers for Scylla, are they hardware or are they virtualized?
So that's on pure hardware. So that's actually a traditional deployment on Linux. No funny business. OSV is considered more experimental with Scylla. So Scylla itself is a product. There's a company supporting it. You as a customer, you can buy it and replace Cassandra with it. They do not recommend running it on OSV yet. But OSV is sort of this ultimate vision of how the system can function.